Hey YouTube, welcome back to another video. Today we'll be talking about vertical and horizontal reflections. So here I am again on Desmos. For this unit, I think I'll be sticking to it pretty closely. So to start off, let's just graph out the normal function y is equal to the absolute value of x. So if you guys notice, it's the standard absolute value of x, but in this video, what I want to be focusing on is I want to focus on how I can reflect these functions. And more specifically, I want to reflect these functions so that they go completely over the x-axis, or they can go completely side to side across the y-axis. So let's start by focusing on the x-axis first. So I want to make this function so it's completely flipped over the x-axis. Now, the first thing that comes to my mind is what if we just multiply all the y values by -1? Because if we multiply everything by -1, then that surely means that everything is flipped, right? So if I just add a times, and then I just put -1 here, and would you look at that? Everything just got flipped here. Now I'm going to draw the normal function, absolute value of x, just for reference here, so you guys can see. So notice how in this function we have some identifiable points, like for example, let's check 4. Now if we multiply our entire function by -1, you'd expect our y values to just change to -1, and then that's true. We keep the x value the same, but we're now at the point -4 instead of -4. Sorry, -4 instead of -4. And this applies to all other points in the function because we're keeping this value the same. We're multiplying all our y values by -1. We could check the point 2, and we'd expect it to arrive at -2 because we multiply the y value by -1. And we could even try a different function out. Let's say we wanted to try x squared out. So we can say y is equal to x squared. And all we have to do is we just have to multiply this function by -1. So we do times -1. And there we go, everything's flipped. And I'll draw in the parent function for reference. Whoops, there we go. So if you notice, it's just a complete vertical reflection across the x-axis. So we kept the function the same, but since we're multiplying it now by -1, we're reflecting across the x-axis. So you can see some points out, like normally 4, sorry, would be at now to -4 because we multiplied that y value by -1, just flipping it across the x-axis. So hopefully that makes sense. Now let's move on to horizontal reflections. So now that we know how to now we know how to do vertical reflections across the x-axis, let's try to focus on horizontal reflections. So I'm going to graph the function y is equal to the square root of x. So you might not be familiar with this function right now, but all you need to know is just how the general shape of it and what it looks like. So I'm noticing here key identifiable points 0, 0, 4, 2, and stuff like that. But what I want to do here is I want to reflect this function so it goes all the way across the y-axis. Now, you might be thinking, the negative, just multiplying the entire function by -1, well, that just flips it vertically, right? Because what we're doing here, oops, let me graph the function, because what we're doing here is multiplying all the y values by -1. But in order to flip it horizontally, instead of multiplying the entire thing by -1, we multiply inside the x. So we're going to multiply -1 inside the x. So there we go. Would you look at that? We just did a horizontal reflection across the y-axis. So what we're essentially doing here is we're just multiplying all of our x values by -1. And I can even simplify this down. I could just say minus x to keep things simple. And this 0.42 would now be at -42. Notice how we keep the same y value, but our x value is now negative because we multiplied this x by -1, right? So you could check out even more points. Let's say we wanted to check out the point 93. So normally the 0.93 on the graph would be here, but now since we multiplied this by -1, it will be at right here, -93. So there we go. That is a horizontal reflection, and this applies for any function really. I mean, I could graph the cube root function. Let's say I wanted to graph. Let's just do x cubed, right? So in order to translate this vertically, you guys can pause the video, and you guys can see what I'm about to do. So all you have to do is multiply the entire function by negative. So we have -x cubed. And notice how it's a vertical reflection. This part is going down here. This part is going up here. So that's a vertical reflection. And in order to do a horizontal reflection, we have to keep it inside the x. So we do -x. And then we do cubed. Whoops. There we go. It might be hard to see, but all we're doing is reflecting all the x values across the y-axis right there. And there we go. Now I will get into some slides I have prepared here. So a vertical reflection is a reflection across the x-axis. So we just learned that. So what it looks like in this notation is we basically have our normal function f of x, and we're just multiplying the entire function by -1. So in this case, all the y values are turning into -1. So here's a cool picture I made here, so you guys can see the smiley face. It's being reflected all the way across the x-axis. So all the points are reflected while keeping the same x value. So let's move on. A horizontal reflection is a reflection across the y-axis, so it's the opposite. Instead of going up to down, we're going left to right. So the way this looks like in math words is you have the normal function f of x, and we're just going to multiply all of our x values by -1 to just flip them over across the y-axis. So now instead of having an image like this, you'd be reflecting across the y-axis. Hopefully that makes sense, and I'll see you for some practice work.